Hello, my name is Ardi and we are going to solve this problem here. So the question is, given the circuit in this figure here, calculate the current I1 through I4. So the question is asking us about I1, I2, I3, and I4. And I think I will use nodal analysis. So we will have to use nodal analysis here. Okay. Let's do what can we extract from the circuit here. So we have two nodes here. This is the first node here. Let's name this node here as node A. So the voltage here is VA. And also we have this node here. And let's name this node B. So the voltage here is VB. Okay, and then let's set the bottommost node here as our ground. And so the voltage here will be 0. The voltage here will be 0. Then we need to assume the direction of the current. And we already given the direction. I1 going down, I2 going down, I3 going down, I4 is going down. But it leaves us with the branch with the current source. Just follow the current. So this is going up. So I will also assume that is going up. This is going to the left, so I will assume it is also going to the left. And then this is going up, so I will also assume it is going up. Okay, now what can we do? We can do KCL at all nodes. So the principle of nodal analysis is do KCL at all nodes. Here we have VA and VB. So we need to do KCL at VA, and also we need to do KCL at VB here. Let's do exactly that. So the first thing that we need to do is we need to do KCL at node VA. Okay, KCL said that the sum of the current that goes in will equal to the sum of the currents that goes out, right? And there are two currents that goes in here. We have this one and that one here. But this one is 6 ampere. We know the value, so we will have 6 ampere there. So we will have 6. And then this current here is 3 ampere, so we'll have plus 3. And then all the other currents are going out. So we will have I1 here, I1, and then this one will be I2. So I will have plus I2. Good. Now 6 plus 3 is 9. But then we need to calculate I1. But we don't have I1 here. We only have the voltage and a resistance. So we can use Ohm's law to do this. So we will have VA. VA is where the current comes from. It comes from this node, right? Which is VA. And then minus where the current goes to. This is 0. So we'll have VA minus 0. And then it is divided by 20 here, which is the resistance between them, because current is just voltage divided by resistance, right? It is Ohm's law. And then for I2, it is similar. We will have VA and then minus 0 here, VA minus 0 divided by the resistance between them, which is 10. Good. Now what can we get from here? Let's multiply both sides by 20 to get rid of this and that, right? 9 multiplied by 20, that will be 180. And then 20 and 20 will cancel each other, and it is leaving VA minus 0, which is VA. Okay, and then we will have 10 and 20 will cancel into 2, and 2 multiplied by VA minus 0 will be 2VA. Okay, that is good. VA plus 2VA, that will be 3VA. And let's move this 180 to the right hand side. So we'll have 180. And then we will have VA is equal to 180 divided by 3. So we'll have VA is equal to 60 volt, which is a very nice value here. So our VA here is equal to 60 volt. Good. And we have done for VA. Now we can do similar game for VB. Let's do exactly that. Let's do KCL at node VB. Again, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, let's see there. The only current that goes in is this one here, which is 2 ampere. Good. And then this current is going out. So I will have 3 on the right-hand side here. And then we also have I3 and I4 all going out. So I'll have plus I3 and plus I4. Let's subtract both sides by 3. So we'll have I3. So I will have minus 1 on the left-hand side. And that will equal to I3 here. So I3 is VB minus 0. VB is where the current comes from. And then 0 is where the current goes to. And it is divided by 40. And then plus, we will have this one here. So we'll have VB, then minus 0, again divided by 40. Multiply both sides here by 40. So we will have minus 40. And then this 40 and 40 will cancel each other. So we'll have VB minus 0 plus VB minus 0, or that is just 2VB. Okay, and therefore we will have VB is equal to minus 40 divided by 2. We will have minus 20 volt. Good. And now we have our VB, which is minus 20 volt. And I think that is good because we have all we need to calculate I1, I2, I3, and I4. However, our slide is full. Now let's erase this first. Okay, now we have all the values needed to calculate all the currents. And let's calculate that. So I will have I1 here is equal to this current, which is VA, 60. Then minus 0. 60 is where the current comes from. 0 is where the current goes to. Divided by the resistance between them, which is 20. So 60 divided by 20, we will have 3 ampere. That is for I1. And then what is I2? Similar. Here we will have 60 minus 0 divided by 10. Right? 60 is where the current comes from. 0 is where the current goes to. And then 10 is the resistance between them. So we will have 6 ampere here. Okay. Now let's do I3. I3, we will have this one here where the current comes from, minus 20. And then where the current goes to, 0 here. So we'll have 0 divided by the resistance between them. So I'll have 40. And so we will have that will be minus 20 divided by 40. We'll have minus 0.5 ampere. And then we will have for I4. I4 is equal to, again, minus 20 minus 0 divided by 40. So we'll have minus 0.5 ampere. And I think that's all for this problem. We have calculated I1, I2, I3, and I4, which is the one that is asked by the question. Hopefully I did not make any mistakes in my calculation. Thank you for watching and see you in the next video. Bye-bye.